We're beginning a new chapter, and in chapter 2, we're going to geometric shapes like lines and circles and triangles and distances. And so in section 2.1, we're going to be doing distance and midpoint formulas. The distance formula is the first one we're going to go through, and I have here drawn a right triangle. I want to just go over some parts of it first. If we call the first point x1, y1, and we call the second one x2, y2, then the third point, it would maybe make sense if we called it x3, y3, except for it shares some of the same coordinates as some of the other points. So instead of calling it x3, y3, let's call it the same x value as the point above it. So it's going to be x2, and then the same y value as a point side by side with it, y1. And we can say the distance A is a distance between point 1 and point 3. We call it the distance between point 1 and point 3. But since that's on a horizontal line, we could just say it's the distance, the difference between their x's. And we can say the length of B is the distance between point 2 and point 3. And that is also the distance vertically, so we can say it's the distance between their y values. And point C, or length C, would be the distance between point 1 and point 2, which is what we're trying to find right now. How do we find that distance? Well, we don't know yet, so what we're going to do is say, hey, we know that this is a right triangle. We're going to use the Pythagorean theorem, which said a squared plus b squared is equal to c squared. And I'm going to just put that on this side. I'm going to replace that with x2 minus x1. I'm going to replace the b with y2 minus y1. And you say, there we go, that's giving us c squared, but I don't want c squared, I want c. Well, then I'm going to square root both sides. And normally when I square root both sides, I put a plus or minus symbol, but because we're talking about distances, we're not going to have negative distances. And so we have the formula for c, which is the distance between the 2 points, as this. And so I can say the distance between point 1 and point 2. Notice that the 1s and the 2s are lower than the values. Those are called subscripts. And when we use a subscript, it is not an exponent. We have to be very careful because we have some exponents here. We have a squared and we have b squared, but we have x2 and x1 as subscripts denoting which x we're talking about. We're going to use this formula to find distances. Now when we're doing question number 1, it really doesn't matter which one we call point 1 and point 2. It's just when you have 2 points you're going to do this. It doesn't matter because even though it would be different if you said x2 minus x1 versus x1 minus x2, after you square it, those are going to both be positive, so it doesn't matter which one you do. So I could say 6 minus negative 4, the distance between that squared, plus 2 minus negative 3, the distance between the squared and then the square root. That becomes 6 plus 4 plus 2 plus 3, which then becomes 10 squared plus 5 squared, which is the square root of 125. And we want to simplify that so we can break that down into the square root of 25 times 5. And we're going to say that's 5 radical 5. Now, I want to point out, if I do it the other way around, I would get negative 4 minus 6 squared plus negative 3 minus 2 squared. And if I did this, I would get negative 10 squared plus negative 5 squared. And then I would still get 100 plus 25, which would still be the square root of 125, and it would still give me that answer. So once again, it doesn't matter which order you do it, because you'll still get the same positive answer. For number 2, it actually gives us several questions in one. It asks us to plot the points and form the triangle ABC. So I already drew my grid. We're going to plot the points negative 2, 5 is over here, 12, 3 is over here, and 10, negative 11 is right around here. And I'm going to connect them. And so I have this here. It says to prove it's a right triangle. I'm going to guess that that's this angle here is where we're trying to prove it's right. So I want to show that these two sides, and when I use them in the Pythagorean theorem, that they end up proving that the third side is the hypotenuse. So what we need to do is find the distance between all the points. So the distance between A and B, and then we're going to get the distance between B, A, and C. And the distance between B and C. To show that this is a right triangle, we will do one of the sides squared plus the other side squared is equal to the third side squared. And so when I square those, I'll get 200 plus 200 is equal to 400. Since it fits the Pythagorean theorem, then it is a right triangle. Now it does ask us to find the area as well. To do that, we want the base and the height, and we want to multiply it by 1/2. And so the base would be one of our 10 radical 2's, and our height would be our other 10 radical 2. And so we're going to get 1/2 times 100 times 2, which is just 100 square units. We always want to say square units when we're doing area. Alright, that was quite a lot of work, but we found all the distances, and then we used the Pythagorean theorem again to show that it was indeed a right triangle, and we used the length and the width of that right triangle, but not the hypotenuse, to find its area. Next, we have the midpoint formula. I just want to point out right here that we are finding a point. It says midpoint. So all I'm doing is finding a value for x and y to put in my point. But we do that by solving for x and solving for y using this formula here. Now, it's not a hard formula, but it is easy to get confused with the other one, because here we are adding our x values instead of subtracting them. So you just have to be careful with that you're sure if you're finding the distance versus the midpoint, you're going to be adding or subtracting. That can be very easy to get confused. So we get the midpoint between these two values. We're going to say x1 plus x2 divided by 2. We're going to do y1 plus y2 divided by 2. And then we're just going to simplify this to find what the point is. Get 6 over 2 and negative 1 over 2. And that can be simplified one more time. The midpoint is 3, negative 1/2. And if we plotted them, we would see that that is the point right in the middle. So we can plot the 2 points. P1 is at 2, negative 3. P2 is at 4, 2. And if we sort of think about where the midpoint is, it's at 3, negative 1/2. That makes a lot of sense. For this last problem, we're going to go back to the distance formula because it is asking us to find the distance. But it's sort of setting up the problem in a different way than we've done before. I want to sort of collect the information that's told to us. We have a point. We can call it point 1, and it's 1, 2. We want to find another point, or another points if there's multiple of them. And it only gives us the y coordinate, so we don't know the x coordinate, but the y coordinate is negative 6. Then we say the distance between them we want to be 17. So we're going to use the distance formula. We're going to write that in. I'm going to say x minus 1 squared plus negative 6 minus 2 squared. And then I find that distance. I want it to be 17. So in order to solve this, I'm going to simplify some of these. I actually might square both sides also. Get rid of that square root. And I'm going to get x minus 1 squared plus negative 8 squared is equal to 289. So that's x minus 1 squared plus 64 is 289. We're going to subtract 64 from both sides and get 225. And then I'm going to square root this, and that's when I put the plus and minus symbol on. So I get x minus 1 is plus or minus 15. Now in order to solve this, I need to make two statements. X minus 1 is 15, and x minus 1 is negative 15. I'm going to add 1 to both sides. I'm going to get 16. I'm going to get negative 14. So my 2 points would be 16, negative 6, or negative 14, negative 6. And those are both points that have a distance from the point 1, 2. The distance is 17.